Dito sa classification, okay, it's straightforward. Okay, we have objects that you want to classify. Ang unang example na ginamit for machine learning is to classify digits, di ba? 0, 1, 2, 3, 4, 5, handwritten digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so yan, 10, ano yan, 10 labels na kagad yan. So label ang tawag doon. 0 is one label, 1 is one label, 2 is one label, so on and so forth. Okay, so ang simplest of course is binary classification. Pag sinabing binary classification, is just simple yes or no, it's high or low, dog or cat, walking or running. So yan yung binary classification. And these are all called labels. So yes, no is a label, high and low are two labels, dog and cat are two labels, walk and run are also two labels. Okay, an example of a binary classification problem is, for example, itong tumor size. Okay, so can you determine kung yung isang tumor is malignant or not based on the tumor size? Okay, and base dito sa graph, okay, makikita natin na for small tumor sizes, okay, sinasabi natin na hindi malignant yung tumor. And then for large tumor sizes, sinasabi natin na sinasabi ng graph na malignant yung tumor. If we use linear regression, ganito yung magiging result. And makikita nyo na hindi makakatulong ang linear regression kasi if you say you input a tumor size that has this size, okay, ito yung size ng tumor, gamitin nyo yung linear regression, okay, ito yung makukuha nyong result. So you say, okay, malignant siya. Okay, base dito sa results ng linear regression. Okay, halimbawa ang tumor size is nandito. Okay. Pagdating dito, ay ipoproject nyo ngayon yun dun sa blue line, and makikita nyo na, okay, it's somewhat malignant. Okay, so kasi malapit na siya sa 50%. Okay, and kung halimbawa ito ang piliin ninyo, no, tumor size, sabihin nyo, okay, hindi ako sigurado kung malignant or non-malignant yan. Okay, kasi yung sinasabi ng model is it's somewhere here. Okay, so hindi tayo sigurado, 'di ba, kung ito yung model na pagbabasihan natin. Medyo may doubt, okay, kung malignant or hindi yung tumor. And if it's as important, if it's data that's as important as this one, okay, na crucial sa life ng isang tao, then you don't really want a model to base your decision on a model that has this large uncertainty, di ba? Now, what if we add a data point dito? Okay, mag-add tayo ng data point. Makikita nyo that the model changes because a single data point was added. Okay? And, syempre, problematic yun kasi kanina, halimbawa, itong tumor size na to, okay, nung wala pa tong data point na ito yung chance na malignant siya. Pero nung nandito na yung data point na ito, bumaba yung chance na itong tumor size na ito ay malignant. Di ba? So the model changes and how you interpret the model or how you interpret your results based on the model also changes, but just because you added a single data point. Okay, and you don't want that kind of model na nag-change drastically base sa changes in the number of data points. So what you want is a model that gives you high accuracy. Sasabihin ng model sa'yo na, okay, sigurado ako na 90%, more than 90% na yan ay non-malignant or more than 90% na yan ay malignant. Gusto mo na ganun kataas yung confidence mo sa model na yun. Okay, so what you do is instead of anong tawag dito? Instead of a linear function, you use what's called a sigmoid or logistic function. And ang sigmoid or logistic function is gives out this result. H theta will be, anong tawag dito? If H theta is less than 0.5, yung model will give you an output of 0. And if h theta is greater than or equal to 0.5, yung model will give you an output of 1. And if you're doing classification, ito yung gusto mong result. Dun sa linear regression before, yung hypothesis mo is based on a linear function, di ba? Y is equal to mx plus b, or theta naught plus theta 1 times x. Okay, but dito, tignan mo yung hypothesis. Tignan mo yung value ng hypothesis. If it's less than 0.5, then it outputs 0. And if it's greater than 0.5, then it outputs 1. Okay, so yun yung gusto mong mangyari. Gusto mong result. Okay, of course, you also want the hypothesis to have a range which is between 0 and 1, inclusive 0 at saka yung 1. Kasi gusto mo lang na, kasi classification ito eh. So it's either 0 or 1. Okay. So the function that best suited for this is the sigmoid or logistic function, and it has this equation. It follows this equation: g of z is equal to 1 over 1 plus exponential minus z. Okay, so makikita nyo, for example, if z is equal to 0, then you have 1 over 1 plus 1, so 1 half 0, so 50%. If z is equal to 2, positive 2, then the logistic function gives you 90%, 0.9. If if z is equal to negative 2, then this function gives you 0.1. If this is 6, then this function already gives you almost 1. Pag z is equal to negative 6, then this function gives you almost 0. Okay, so makita nyo na ano ang tawag dito? Na kung gaano kaganda tong function ito pagdating sa sa classification, di ba? Kasi mataas kagad kahit na small values ng z, mataas kagad yung binibigay niya sa inyo na result, either 1 or 0. Okay? So, how do you incorporate that sa ating algorithm? So, before, yung h theta, we set it sa linear regression, we set h theta equal to theta t times x, theta transpose of x. Ngayon, we're going to set h theta, the hypothesis, equal to the logistic function where the dependent variable is theta t, theta transpose times x. So yung z dito is theta transpose times x. Okay, so yan yung ating hypothesis. Okay? So, in other words, okay, if theta transpose times x is less than 0, okay, kasi yan yung z, di ba? Remember, this is the z value, ito yung z. So if theta transpose of x is less than 0, so nandito siya, the value of the hypothesis will be 0.5. So you give an output, give a prediction which is equal to 0. And if theta transpose of x is greater than 0, so nandito yung theta transpose of x, the hypothesis will give you a value which is greater than 0.5. So your prediction niya will be 1. Okay, and that's how you basically implement yung sigmoid or logistic function. Okay. So in this case, makikita nyo na this function works much better kumpara sa linear regression. Kasi sa linear regression kanina, diretso lang siyang ganyan. Mababa yung mababa yung accuracy. Pero dito, sigmoid logistic function, makikita nyo na kagad na okay, pag dito natin ilagay yung function natin, okay, sasabihin nito na for values less than 0.5, okay, non-malignant siya. And then for values greater than 0.5, then malignant siya. And notice that if we add data point here, it doesn't change the sigmoid or logistic function that much. Okay, it will still have the same shape. Walang shifting ng slope. It will have exactly the same slope. Okay, may extend lang to ng konti. So, ang mababago lang siguro dito ng slight na changes lang dito at saka dyan. Okay, but it doesn't change. The effect is not the same as with yung linear regression. Okay, so yun yung advantage ng sigmoid logistic function. And for classification, this is a good function to use. Now, yung sa linear regression, sinabi natin na yung theta transpose of x, yun yung function na ginagamit natin. And that's good for regression. Okay, univariate, multivariate, it's fine. Pero for classification, we would like to use this sigmoid or logistic function because it tells you immediately kung 0 or 1 siya. So, itong mga functions na to, ito yung mga tinatawag na activation functions. Okay? And we'll learn more about activation functions mamaya pagdating natin sa neural networks. Okay? So, basically, kaya lang siya tinawag na activation function is because if you insert a data set, okay, ang gagawin na activation function, it will activate that neuron in such a way na that neuron will give you an output which is either 0 or 1. Okay, so kaya siya tinawag na activation function. And that's basically how neurons work, yung single na brain cell. Diba? When you give it an impulse, it processes that impulse and then gives out a value. So the brain, that neuron is sort of activated to give out a specific response to the stimulus. Okay, so yun yung ginagawa nitong mga activation functions ito. And of course, there are a lot more activation functions. Depende sa kung ano yung data na pinoprocess mo. Okay, and you learn more about that in the next sessions. Okay. Okay, now before we proceed to neural networks, let's talk about decision boundaries. Now, of course, marami kayong iba't ibang types ng dataset. And this is just one type of dataset. Here, para sa atin, it's already obvious kung paano natin i-classify itong ano na to, itong dataset na ito. Okay, we just draw a straight line dito. Okay, then it's easy to create ang tawag dito, a separation between these data sets. Okay. But for the computer, syempre kailangan mo siyang bigyan ng kailangan mo siyang bigyan ng information about the data. Kasi the computer doesn't see this as circles and crosses. Okay, nung pinlat itong data na to, tayong nagplot nito, tayong nagsabi na ito, circulan mo yan, ito ang mga crosses. So how do we tell the computer to tawag dito para ma-classify yan ng computer? So let's try to use yung ano dito, yung ating sigmoid or logistic function. Okay, so obviously this the line, so there's a line that will separate this data set from this data set. And we call that line the decision boundary. Okay. Now that line is, that line is not necessarily a line. It will depend on the type of data set. So in this type of data set, obviously, yung decision boundary is a line. In some data sets, which you will see later, yung decision boundary can be a circle. Okay. So ito yung simplest case ng decision boundary. Straight line lang siya. And alam natin na pag line, since we have two variables x1 and x2, this is a tawag dito, double variable linear regression. So this is double variable line. So magkakaroon ka ng equation of the line theta naught plus theta 1x plus theta 2x para lang magawa yung decision boundary dito. Okay, and what you do to make a classification is tawag dito, define theta naught, theta 1, tsaka theta 2 values. Then you plug it in dun sa logistic function. Okay? Tapos tignan mo kung ano yung hypothesis. Okay, and then if the hypothesis tells you that it's 0.5, less than 0.5, then it classifies it as a zero, as a circle, and if it is greater than 0.5, it classifies it as a cross. Okay, so that's how we teach the computer to learn about this data set. So let's begin with these values of theta. So this is theta naught, -3. Ito theta 1, 2. Then theta 2 is +3. Okay. Ito yung ating theta transpose of x ngayon. Yung theta transpose of x, ito yung theta transpose of x natin. So this is negative. Bakit negative 6 to? Sorry, dapat -3 to. -3 or dapat ito yata yung -6. Okay, sorry. Ulit. Correct na natin para -6 to. Yan. Okay, so that's -6. Okay, 2, 3. So -6 plus 2x plus 3x 2. 2x1 plus 3x2. Okay, if it is greater than 0, then if theta transpose of x is greater than 0, then we say that y is equal to 1. Okay. Okay, so 2x1 plus 3x2 is greater than 6. So nire-write ko lang ito, di ba? Nilipat ko lang yung 6 dun sa kabila. This is the condition for y equals 1. Okay, and if we do that, we have this line. Okay, so this feature values, okay, or weights, okay, will have this line, okay, if it has these values. Okay, paano natin nakuha yan? Let's say, if x is equal to 0, x1 is equal to 0, then x2 is equal to 6 divided by 3, which is 2. Yan, yan. x1 is equal to 0, then x2 is equal to 2. Okay, then if x2 is equal to 0, x1 is equal to 6 divided by 2, 3. So x1 is equal to 3 if x2 is equal to 0. And if you draw a line that connects those 2 points, ito yung line na yun. Now, obviously, itong line na to does not describe, okay, the data set properly. Kasi itong circle, which is supposed to be classified as y equals 0, ay na-classify as y equals 1. So anything above this line is y equals 1, and anything below this line is y equals 0. Okay? So, itong values na to, okay, does not give us the correct decision boundary. Okay, so we need to solve for the decision, we need to solve for a new value of theta, okay, para makuha yung tamang decision boundary. Okay, so tignan natin yung hypothesis dito. So 1 over 1 plus exponential, and then ito yung negative theta transpose, okay, theta transpose x. Okay, let's say na ang x1 is equal to 0.5. Halimbawa, ano bang data set yun? Okay, 0.5. Ito ba yun? Ito. Itong bilog na to. Yan ay x1 equals 0.5 at saka x2 equals 0.5. Okay, so x1 equals 0.5 at saka x2 equals 0.5. So if this is 0.5, so this is 1, di ba? And this is 0.5, this is 1.5. So 1 plus 1.5 is 2.5. Negative 6 plus 2.5 is negative 3.5. Then may negative sign ka dyan is positive 3.5. Actually, ito negative 3.5 itong theta transpose of x, di ba? Negative 3.5 yun. Okay, so asan ang negative 3.5? Dito sa graph. Balikan na. Asan na yun? Yan. Asan ang negative 3.5 dito? Ang negative 3.5 is somewhere here. Okay, so ito yung value niya. Okay, so nandito yung negative, sorry. Dito banda, ang negative 3.5. So ito yung value niya. Of course, pwede naman natin i-compute. May computer naman, pwede i-compute. At pag kinompute nyo yung negative 3.5, ang lalabas na value is 0.029. Okay, and since yung h theta is less than 0.5, then this means that x1 should be classified as y equals 0, which is correct. Diba? So tama lang na ito ay na-classify as y equals 0. Now, what about itong 2, 3? Nasaan ang 2, 3? x1 is 2, and then 3. 2, 3. So, I suppose, ito siguro yun, itong x na to. Okay, so ito yung x1 is 2 and x2 is 3. Okay, so x1 is 2, tsaka x2 is 3. This will give us, di ba, 2. So 2 times 2 is 4, 3 times 3 is 9. So 4 plus 9 is 11. Negative 6 plus 11 is 5. So positive 5. Okay, pag tinignan ulit natin dun sa graph kanina, ito, positive 5 is somewhere here. So medyo malapit na siya sa 1. And in fact, when you calculate it, okay, the theta value is, the hypothesis is just 0.999, which means na this should be classified as y equals 1. Okay, which is correct naman. Tama? Which is correct. Okay. So, well and good pa tayo sa 0.5, tsaka 2, 3. What about 1 tsaka 1.4? Ito yung 1, and yung 1.4 is somewhere here. Ito yung 1, 1.4. This will give us an h theta of 0.55. And since it's greater than 0.5, then this data point should be classified as y equals 1. Well, in fact, pag tinignan natin sa graph, hindi siya dapat y equals 1. Dapat y equals 0 siya. Okay, and the reason it was classified incorrectly is because incorrect yung theta values, incorrect yung weights. Okay, incorrect yung decision boundary. Okay, so I'm sure that if compute for 0.5 at saka 2.5 or 2.2 na ito, it will also give y equals 1, okay, which is obviously incorrect. Okay, so we have to recompute for a new value of theta. Now, if we use negative 3, 1, 1, then we get, okay, negative 3, 1, 1, negative 3 plus x1 plus x2 greater than or equal to 0. Ito yung sasabihin natin na y equals 1. Okay, this will give us x1 plus x2 greater than or equal to 3. And yung decision boundary natin dyan is if x1 is equal to 0, x2 is equal to 3. So dito. And if x2 is equal to 0, x1 is equal to 3, then nandito. So ipag kinonect natin yan, ganyan yung magiging decision boundary natin. Now this looks much, much better. Okay. In fact, okay, when you type in the same data points, 0.5 tsaka 0.5 will give us 0.119, which is expected. x1 equals 2 tsaka x1 equals 3, ito yun. It will give us 0.881, which is y equals 1, which is expected. And if we use 0.3 tsaka 2.2, ito yung 0.3 tsaka 2.2, ito yun. This will give us an h theta, which is equal to 0.375, which is y equals 0, which is what we wanted, right? So because we chose the correct weight values, the correct values of the weights, it gave us the correct decision boundaries and gave us a higher accuracy of, the model will give us a higher accuracy of prediction. Okay, so yan yung ginagawa nitong decision boundary. Okay. Okay. So now this decision boundary, tulad ng sinabi ko sa inyo kanina, it's not necessarily a straight line. It can have this shape. Okay, depending on the data. So itong data na ito, for example, is microchip test data comparing the first test and the second test. Okay. And ito yung results ng test. So mayroon kang plus values tsaka tawag dito, plus data points tsaka yung mga circle na data points. And you want a decision boundary which is this shape. Okay. And to describe this decision boundary, ganito ka-komplikado yung theta transpose of x. And you notice na hindi lang siya linear. Meron siyang second power ng x1, second power ng x2, okay, cross terms ng x1 tsaka x2, cross terms ng second power ng x1 tsaka x2, okay, and so on and so forth. So just to get this decision boundary, you have this complicated tawag dito, equation for the z value for theta transpose of x. Okay, so you will not have, pag ganito yung decision boundary nyo, you will not have 100% accuracy, but you will have an accuracy which is greater than 95%. Okay, now this decision boundary okay, has very high accuracy kasi na-enclose niya karamihan ng mga, nasa-separate niya yung mga crosses at saka mga circles. Right? Okay, which is good. Okay. This decision boundary, okay, has very low accuracy kasi makikita nyo na it encompasses or it covers some crosses and circles, and it also does not cover some crosses and circles. Mababa yung accuracy niya. Now, if you have this decision boundary, more often than not, okay, it's accurate given the data set you use to develop the model. Pero if you have a new data set, may bago kang data point, ipasok mo ngayon dun sa model, it may be that it will give you the incorrect prediction. Bakit? Kasi this model is well suited only for this data set. Okay? At sobrang perfect niya for this data set na pag nag-introduce ka ng bagong data point, posible na hindi siya fit, na yung model na yun will not fit the new data point kasi fit lang siya for this data set. So if that is the case, you call the model, or the model overfits. So merong overfitting. Okay, kasi it's perfect for this data set, but not perfect for any data set that is not trained by this model. Okay. On the other hand, pag pangit yung decision boundary, okay, pangit yung model, it will give you this decision boundary. Then you say that the model is underfitting. Okay, kasi it doesn't give you the correct prediction at all. It has very low accuracy, diba? And yun nga, it doesn't give the correct output. Okay, so ito yung mga dapat nyong iwasan pag gumagawa kayo pag nagde-develop kayo ng model. Okay, so gusto nyo na 100% pag nag-train kayo. But as much as possible, as close to 100%. Pero gusto nyo rin na yung model na yun mag-work for a new data set. Okay, so you don't want that model to overfit. Okay, so ang tawag dito, so you have to really think about these things when trying to develop a model. Kontento na ba kayo sa 95%? Okay, well, of course, the way to check that is to introduce a new data set. Okay, para lang ma-check nyo yung kung yung model ay nag-overfit or nag-underfit. Okay, so what do you do to correct overfitting or underfitting? Okay, so ang gagawin nyo is i-reduce nyo yung number of features. Ang ibig sabihin is itong theta 1, itong mga theta I, babawasan nyo. So you set some theta i's equal to 0 para hindi masama yung mga cross terms, for example, and so on and so forth. Okay, or you do what's called a regularization. Okay, so regularization, you add this term, okay, dito sa cost function. So instead of just having this value, you add this term. Lambda is equal to sum ng lahat ng weights. Okay. And when you add that, this lambda can be any value between 0, can have any value, okay, a positive value. Okay, and that's something that you optimize then. Okay, something that you optimize. Okay, like for example, itong dataset na to is takes a look at the dependence of the price of the houses on the size of the houses. At ganito yung actual na result. Ito yung model na gusto nyong i-fit dito. Okay, which is a good model kasi kung titignan niyo square root ito, di ba? So parang cubic, quadratic yung ano niya. Not cubic. Quadratic. Okay, yung function. Okay. And this one, if you fit it with this, it may overfit. Okay? Okay, pag ginamit nyo ito dito, it may overfit kasi mukhang namang hindi cubic to. Mukhang hindi rin ito fourth power. Okay, so what you want to do is to make this small. Okay, para ma-fit to ng mas maayos. Okay. So, and you do that by applying a constant in front of this theta 3 at saka theta 4. dun sa cost function. One of the ways para ma-improve yung or ma-avoid natin tong underfitting tsaka overfitting is to use regularization. So it's one of the techniques that is used. Okay, and yung regularization is simply a correction to the cost function. So you add this term to the cost function, which is basically the sum of all the features, okay, or weights, okay, squared and multiplied by this value lambda. So ang ginagawa ng lambda na to is just to decrease yung effect nitong higher order terms. You still want these higher order terms para mag-improve yung accuracy. Okay? But you don't want them to overpower itong mga to. Kasi remember, this is x cubed, this is x fourth, and definitely it will overpower yung x squared tsaka x. Okay? If you don't control yung values ng theta 3 tsaka theta 4. And the way to control that, you multiply this, you multiply theta 3 tsaka theta 4 with sa cost function by lambda. Okay, so that's how basically how regularization works. So what we're going to do now is from sa linear regression, ito yung expression natin for the cost function. But starting from now, we rewrite the cost function as this. Cost function is equal to h. Cost function is a function. Excuse. The cost function is a function of this cost na function. Okay? Na function siya ng hypothesis at saka nitong true value. Okay, in this case, ang expression is 1/2 h theta of x super I minus y super I squared. Okay, na kung saan yung h theta ay itong sigmoid or logistic function. Oops. Now, if we do that, okay, we can actually rewrite, or if you want this type of cost function, okay, we can actually write the cost function as this. Negative logarithm of hypothesis if y is equal to 1, and negative log 1 minus the hypothesis if y is equal to 0. Now ito, this negative log of the hypothesis has this shape. And this cost function ito, to negative log 1 minus h theta has this shape. So
Low po, sir.
it
Sir,
still
wala akong
behaves as a sigmoid logistic function, but this is a logistic regression function. And it's easier to use kasi pwede natin kunin yung derivative dito. Okay, no, mas madali. Okay, and we want the derivative kasi we're going to need it to compute for the gradient. Okay, so this is now our cost function, and this is actually how we write it. Okay, bakit ganito? Kasi we want this to give out either 0 or 1. Okay, depende sa value ng h theta. Okay, how does it work? So if y is equal to 1, if you want to classify y equals 1, okay, then this is 1. This is 1. So itong term na ito mawawala. And then we have this cost function, okay, which is just essentially this. Now, if y is equal to 0, then this is 0, and this is 0. And then we are left with this, which is essentially this. Okay, so we write the cost function in terms of this equation. Okay, para ma-incorporate both y equals 0 tsaka y equals 1. And then we use that dito sa ating actual na cost function. Okay, and then we take the derivative. Okay, so ito yung expansion. Okay, so we replace this with this. So yan na yung magiging expression natin ngayon. Okay, and then we take the derivative, and it turns out, okay, that when we take the derivative of this logistic regression function, turns out that it's exactly the same. It has exactly the same expression, okay, for as that of yung linear regression, yung na-derive natin sa linear regression. Okay? 1 over m sum ng h theta xi minus yi times xj. This is exactly what you see dun sa linear regression na pinag-aralan natin before. Ang difference lang is that itong h theta is given by 1 over 1 plus exponential minus theta
Hello,
transpose
sir.
of theta transpose times x. So ito lang yung iba. Sa linear regression, this is theta
Iyan.
transpose ng x. Dito sa logistic regression, is this expression. Okay? Okay, and then you iterate. So that's how you implement the logistic regression. Okay, so take the gradient. This is how you compute for the gradient. H theta is given by this. So once you compute the gradient, multiply it by the learning rate, and then you correct the weights or the features. Okay, and you do that for each iteration. Okay, just for comparison, ito yung linear comparison between the linear and logistic regression. So the cost functions for the linear regression has this expression, for the logistic regression has these expressions. Okay, and pareho lang of course yung update equation. So ito yung equation that updates the theta parameters. Okay, and okay, in MATLAB, this is how you implement it. Okay. Anong pinagkaiba dito? Ang pinagkaiba is ito. Pinalitan natin itong expression for the cost function. Ito lang yung nadagdag, yung h. Ito. Yung h na to, imbis na theta transpose x yan. Dati theta transpose x ang nakalagay dyan. Ngayon, h na yung nakalagay. And you have this sigmoid function. Okay, the sigmoid function is 1 over 1 plus exponential minus x.